Oh, so here we go. So this is a probability. So we're on question number 1, discrete probability. So this is a probability distribution. What if I said to you the chance of rain tomorrow is 0.1, 0.10, pretty low. And the chance that it will not rain is 0.80. Could that be? No, that's impossible, huh? Right? Why not? What do they have to, what's wrong with that? Yeah, they have to add up to be 1.00, which is the same as 100%. There can't be a 10% chance of rain and an 80% chance that it will not rain. That can't be. No, I've had students in the past say, well, yeah, maybe you could, Mr. Chair. Maybe, you're leaving out like foggy or cloudy or other weather patterns. No, that's not right. Think again. It could. I'm not that it couldn't be cloudy or foggy. It certainly could. But if it's cloudy or foggy, that's included in the not rain, huh? That's in there. Make sense? So when we say rain and not rain, that's everything. If I say blue and not blue, that's everything. If you say, is that person's name Joe or not Joe? That's everything, right? When you say something and the not, that's everything, right? If it's foggy but no water comes down, that's called not rain. Huh? If it's cloudy but no water comes down, that's called not rain. So if you do rain and not rain, that's got to make 1.0. That's everything. So this couldn't be. What's my point on that? That's what has to happen in a probability distribution. Those have to total 1.0 or it's just not right, huh? They have to be everything that can happen. They have to total 1.0. So therefore we can find the missing one, right? That's what they want me to do. So 0.3, 0.1, 0.5, those add up to 0.9. So what's missing? It's got to be 0.1. So I added up what was there. It came out to 0.9, and then I subtracted it from 1.0. It came out 0.1, and I put it in there. That's all they want you to do on number 1. Is fill in the missing slot so that the total will be 1.0. Because it's got a total 1.0. A probability distribution shows everything that can happen. We're not even paying attention to these numbers. We don't even know what those numbers are. We don't care. We're just adding up the probabilities. They got to be 1.0. So here's number 2. Put a 2 over there. Suppose you're offered the following deal. You roll a 6-sided die. Now, we did some of these kind of things last time, didn't we? Trying to remember. I teach some other stats classes I mentioned, so I forget what I've done in which stats classes. It's all sort of similar. Fresno City, I'm doing stats, and they're at a different place, and I get confused. So did we do the dice rolling in here last time, or talk about some? We did, right? I'm thinking we did, right? So if you roll, so here's the deal. If you roll a 6, you win $6. If you roll a 4 or 5, you win $4. Otherwise, you pay $5. Okay, so they want me to complete a probability distribution table based upon that. So how are we going to do that? Well, the X is the different amounts of money that can happen. You can put them in any order you want. It doesn't really matter. So if you roll a 6, you win $6, so I'll put a plus 6 there. If you roll a 4 or 5, you win plus $4. And if you roll, otherwise you pay $5. How do you do pay $5? -5. Yeah, it comes out of your bank account, right? And again, you could have put those in any order. It doesn't really matter. But you have to put next to them the correct probability. So what's the probability of this first result that you're going to get $6? Yeah, you got to roll a 6 to make that happen. So it's 1 divided by 6. I don't know if they want a decimal there or a fraction. Honestly, I don't know. Give them either one they want. And the next one, the plus 4, what do you got? What do you got to do to get a plus $4? You got to roll a 4 or a 5. What's the probability of that? Yeah, 2 divided by 6, which reduces to be 1/3, or maybe they want a decimal there. I don't even know what they want. Either one. Give them what they want there. And then finally, how do you lose $5? Otherwise, huh? anything else. So what's the probability that you get otherwise? How many other results are left? Yeah, 3 other results are left out of 6. Huh? Is this making sense? So this right here is if you roll a 6. This right here is if you roll on the die a 4 or a 5. And this is if you roll otherwise, meaning not those, which would be 1, 2, or 3, huh? Is that making sense, the game they're describing? So if you roll 1, 2, or 3, 3 out of 6 probability, you'll lose $5. If you roll 4 or 5, 2 out of 6 probability, you'll gain 4. If you roll 6, 1 out of 6 probability, you'll gain 6.
It says from smallest to largest.
Oh, does it? Where does it say that?
Right there.
Oh, yeah, I see it.
I still don't see it.
Right where you put the 2 at,
It
on
was
the
the
right
X
side.
value where X is the profit from smallest to largest.
Oh, there it is. I should read. Complete the PDF table. List advice from smallest to largest. I'm supposed to go smallest to largest. Let me try again. Thank you. All right. So from smallest to largest. So the smallest amount of money is the what? The minus 4. That's the lowest number there, right? And then the plus 4. Oh, is it minus 5?
Yeah.
Oh, you're right. You're right. Thank you. I'm really messed this one up. Minus 5 plus 4 plus 6. There we go. So that's smallest to largest. Thank you. And the probability again. So how do you get the minus 5? If you roll 1, 2, or 3. So that's 3 divided by 6. How do you get the plus 4? If you roll a 4 or a 5. That's 2 out of 6. And how do you get the plus 6? If you roll a 6. That's 1 out of 6. There we go. So it does matter what order, just like I was saying. Smallest to largest. It doesn't matter in the calculation in the end, but they care, so we'll do it. Find the expected profit. What's the expected profit? So remember how we do this? What do we do? Put L1, L2. Just put that in L1, put that in L2, hit the buttons on your calculator, hit the stat, what is it, calc, 1 var, L1, L2, hit enter. So my X bar, I mean. So what we're looking for is the X bar. That's the average. And I'm getting negative, whoops, decimals in the wrong place there. Negative 0.1, 6 is forever. They want me to round to the nearest cent. So it's negative 0.17, huh? That's the expected profit. That's the average value. So what does that mean? What does that average value mean? On average per roll. That means every time you roll the die, expect to lose about 17 cents on average. There's no way to lose exactly 17 cents on one roll, but that'll be your average over time. We good there? Is that coming out okay? All right, I'm going to keep going. Interpret the expected value. What does that mean? If you play the game many times, you will likely lose an average very close to 17. Oh, there we should look down there. There's the answer. Yes, there it is. And then D, based on the expected value, should you play this game? No, this is a gambling game, and it is always a bad idea to gamble. I don't think that's the right answer. Let's see. So no, it's a gambling game. No, since the expected value is negative, you would be very likely to come home with less money if you played many games. Yeah, there it is. So on average, you're going to lose. So if you want to lose money, you can play the game, but you will lose money on average. There it is. There's the answer. So we all good on that? Questions on that one? What's that? Lost back here? All right. Number 3. The Student Council is hosting a drawing to raise money for scholarships. They are selling tickets for $6 each and will sell 900 tickets. There is one $3,000 grand prize, 2 $300 second prizes, and 12 $30 third prizes. You just bought a ticket. Find the expected value for your profit, round to the nearest cent. Just like from last night's homework, the last problem, number 14, not the quiz, but 3.3. So, all right, so remember how whenever you're figuring out insurance, warranties, or gambling, basically something with randomness to it, all you have to do is you got to set up net dollars and probability. You just got to make a big table, and then you got to list every different kind of thing that can happen financially speaking. So what can happen? If you're going to buy one ticket, what are the different things that could happen? You could win the grand prize. So you could win the grand prize. If you win the grand prize, what will happen to your bank account? Net dollars. Remember, it's always net, everything considered. Well, they're selling the tickets for $6, and you win $3,000 grand prize. So 3,000 minus 6, which is whatever it is, 2,994. You can just type it in just like that, though, to your calculator. It'll handle it just fine. Does that make sense how I came up with that? If you win the grand prize, how much are you going to win? Well, $3,000, but you had to pay $6 for the ticket. So the net effect to your bank account is whatever that difference is, huh? Is that good? Next, you could win one of the second let me hold up. What's the probability of that? Well, over here, what's the probability? What's the chance that you're going to win the grand prize? There's 900 tickets. Yeah, you bought one. 1 divided by 900. There's only one winning ticket out of 900. Is that making sense? Next, you could win second prize. So if you win the second prize, there's 2 of those, you get $300. But again, subtract 6 because you had to pay for the $6 ticket. So the net effect to your bank account is 300 minus 6, $294 gain. What's the chance you're going to win one of the second prize? What's the probability of that? 2 out of 900, huh? Because there's 2 second prizes. So 2 out of 900 people will get second prize. What else could happen to you? You could get one of the 12 third prizes. If you get a third prize, you'll get $30. But again, subtract the 6 because you had to pay $6 for the ticket. So you really only made $24. What's the chance you're going to get a third prize? Yeah, there's 12 of those out of 900 tickets. 12 out of 900. See what I'm doing there? I'm just writing net dollars, probability. Net dollars, probability. Net dollars, probability. That's all you do on these insurance or warranty or gambling problems. It's always the same thing. This way we figure out the average or expected winnings. Expected value is called. The average of what's going to happen. And what's the fourth thing? You could win first the grand prize, second prize, third prize, or you could lose. You could win nothing. And what will happen to your bank account if you win nothing? You'll just lose the $6 you paid for the ticket. And what's the probability of that? Yeah, 900 minus all those other things, huh? Is that making sense? We got to take the 900 and subtract the 12, subtract the 2, subtract the 1. Because 12 tickets will get third prize, 2 will get second prize, 1 will get first prize, the rest will get nothing, huh? So whatever that is, 15, 885, I think. So that'd be 885. 885 tickets out of 900 will get nothing. So that's likely. Is that good? See how I came up with that table? So anytime you have insurance or warranties or gambling, you just put the net, the different things that can happen to your bank account, and the probability of each of those things occurring. And then just put it in your calculator, L1, L2. And if you're interested, by the way, like in the by hand, when we do that, you can do this by hand really easily. All the calculator's doing when we type in L1, L2 and hit the buttons, it's just multiplying the left side times the right side. Left times right, left times right, left times right, and adding them all up. That's all it's doing. You can do it by hand pretty easily. It's just taking the numbers on the left times the numbers on the right, adding them all up. So, but it's nice to have the calculator do that for us. But it's pretty easy by hand. It really is pretty easy by hand. So let's put that into the calculator. Negative 1.6. $1.60 in other words. Negative $1.60. Let's move on. All right, so number 4. 60% of all students at a college. Okay, so 60% of all students at a college still need to take another math class. That's not you all, maybe. Maybe this is it for you. If 35 students are randomly selected, find the probability that exactly 20 of them need to take another math class. Let's absorb that question for a minute. Let me let it sink in. 60%, suppose that's true at this college. 60% of all students at, say, this college still need to take another math class. So if you grab 35 students randomly, you just wander around campus. Suppose somebody tells you, hey, 60% of this student body at this college need to take another math class, and then you wander around campus at random, and you just ask 35 people at random, do you need to take another math class? What's the probability that exactly 20 out of the 35 you ask will need to take another math class? Well, that's kind of a weird question, isn't it? And then they're going to ask us, what's the probability at most 23, at least 21, and between 17 and 24, out of the 35 you ask, will need to take another math class? We've entered a whole new world here. And that is the world of binomial. You see it right down there. There it is. Binomial probabilities. This is a binomial question, and we're going to do it on the calculator, but let me show you how. First off, why is it called binomial? Why is a bicycle called a bicycle? It's got 2 wheels. Bi means 2. So binomial is a question that has 2 answers. Either you need to take another math class or you don't. In other words, here's another way it would not be binomial. If they said, hey, I'm going to go around campus, ask everybody, 35 people, how many more math classes do you need to take? And they could say 0 or 1 or 2, or maybe they need 3 more math classes. Whatever, they could give me a number. That would not be binomial, because there would not be just 2 possible answers. There'd be lots of possible answers. But you can change it into a binomial question by saying, do you need to take another math class? Yes or no. Then it becomes binomial. Does that make sense? So binomial is when you just have 2 possible answers to a question. So they're asking here a binomial question. Do you need to take another math class or not? They asked 35 students. So that makes it binomial. And so we go to our calculator and do the binomial thing. So let me show you. All right, so here is the information for doing. Now, where do you find this binom stuff? Well, let's first off find what we need to do, and then we'll do it. So exactly 20. So the first one says exactly 20. So we're going to do, here's the exactly, you do binom PDF. So first notice that the exactly has binom PDF. All the rest don't have PDF. They all have CDF. CDF, which is a different function. They're both in your calculator. I'll show you where they are in just a second. CDF, CDF. These are all CDF, right? So the only one that is binom PDF is the one that says exactly. So when they say exactly, that's one specific spot. It's not a range. And so notice that it's PDF there. All the rest have CDF, 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 CDF. All right, so exactly as binom PDF. Let's do it. So it's going to be binomial, stands for binomial probability distribution function. Number of trials, I'm going to explain all that. Number of trials, comma, probability, and then 20. Because they said exactly 20. Good there? Is that making sense? It's under distributions. Let me write this a little better and I'll show you. So where you find that thing on your calculator is you have to first hit second. Got to hit that second button in the upper left-hand corner, the blue one. Hit the second button, and then it's right above the word vars, variables. It's distribution up there. You're choosing the distributions. So hit second and vars, which is really second and distributions. You know, you're getting what's above that button when you hit second. So you're getting the various distributions. We're going to use this for like this week and next week. We'll be doing a bunch of the different distributions here. You'll see on your calculator screen, the first one is normal PDF and then normal CDF. You see in those? If you roll down, go way, way down near the bottom, you'll see binomial PDF. You have to go on down below the screen. You'll find binomial PDF and binomial CDF. So we're only going to use binomial PDF for exactly. Hit enter. Hit enter on binomial PDF. And then what's the number of trials we're going to put in here? How many? That's how many times we asked people over and over again. That'd be the 35. 35 times we tried this. We asked them, do you have more math classes to take? And then what was the probability each time that they would say, yes, I have another math class to take? 60%, 0.60, because 60% of the campus needs to take another math class, right? So every time you ask somebody, there's a 60% chance they're one of those people that need to take another math class. And then the 20, that's the number we're trying to find out if it's exactly that number. So put in binom PDF, not CDF, PDF, 35, comma, 0.6, comma, 20. You don't even need the closing parenthesis. And I'm getting the answer 0.1275. I don't know how many does it say how many decimals? Okay. 0.1275. It goes on.
Answer to the nearest fourth decimal.
4 decimal, thank you. 4 places. There it is. So let's try the next part. Let's try part B. Part B is saying at most 23. So how do we do at most? Well, here I've given you the instructions. At most 4. So what if I said I have in my pocket at most 4 coins? That means I have 0, 1, 2, 3, or 4, huh? At most 4. So if they say at most 23, let me bring it down here. At most 23, if I said I have at most 23 coins in my pocket, that means I could have 0, 1, 2, all the way to 23, huh? That would be at most 23. Does that make sense? And so what do we do? We're going to do the binomial. Now, is it PDF or CDF? CDF, yeah, because the PDF is only for the exactly. Everything else is CDF. What the C stands for is cumulative, meaning they all pile up. And if you want this simple rule, some of you this will work for. Some of you, I'll do both. So basically, what the thing's doing when you go number of trials, probably that's going to be the same number of trials. That won't change. That's still 30. That's how many students you're asking. 35 students. Probability. That's the probability every time. 0.60. That doesn't change at all. But then what comes at the back? What is that number? Whatever you put back there, it's that number or less. That's how the Binomial CDF program is written in your calculator. It's actually a program. Somebody programmed it in there to work that way. So anything, if I give it 10, it's going to actually take 10 on down to 0. 10 or less. If I give it 15, it's going to take 15 on down to 0. That makes sense? That's all it does. It takes from there on down. Now, that means if you want that number, what number do we want? Number or less? We want 23 or less, don't we? See how that works? We want 23 or less. That's why I'm saying if you're doing the at most, you just put in that number. See how it said at most 4, and I just put in 4 right there, 4 or less. No need to take I'll explain that in a minute. Just do it straight like that. And hit the buttons on your calculator. 0.8048. Is that coming out? Is that making sense? Let's go on to the next one. So next one, at least 21. At least 21.
What's with the instruction then one subtract the answer?
We'll get there.
Okay.
And this one, we'll use it on this one. So now we need to do at least 21. We good there? Let me go to a fresh screen. So at least 21. Whoops, I did the wrong thing there. There we go. So they're saying at least 21, so that's again going to be, well, we'll think about what at least 21 means. If I said I've got at least 21 coins in my pocket, what does that mean? I've got 21 or 22 or 23 or more. It means 21 or more, doesn't it? At the least, at the lowest, 21, maybe more. That's what that English phrase means, right? At least 21. So, binom, CDF or PDF? CDF, always cumulative unless it's exactly. Number of trials, it's always number of trials, probability, number of trials, probability, and whatever I put here, it's that number or less. Now think logically with me. I mean, you've got the rules and you can certainly put those on your sheet and use those during the exam. But you'll do better. It'll be quicker for you. And the homework and the quizzes and everything, if you really get why I'm putting all that funny stuff up there. It's always better in math to understand than just to follow. But I mean, you kind of got to do both. So anyway, so think about how the programming works. Whatever you put right there, it's going to take that number or less. So if I was to stick a 21 there, it would think, what it would do is 21 or less. But that ain't what I want. I want 21 or more on this question. That was great on the last question. On the last question, I wanted 23 or less, didn't I? I wanted 23 down to 0, so I just stuck a 23 there, 23 or less. That's what I want. That's what it does. It's all good. But on this one, I don't want 21 or less. I want 21 or more. So I better not stick a 21 there. I don't want less at all. I want more. So I got to do the opposite. That's why the 1 minus. That's why the 1 minus comes into play on a couple of those. Because it's all the ones where you're doing more, right? All the ones where it goes higher. All the ones that go at least 4, more than 4. Those are all going up, aren't they? So in all those cases, you got to do 1 minus the answer at the end. You got to do the opposite, because that's the opposite of less. It's more. Whereas the at most 4 and the less than 4, those are both less, so there's no need to take the 1 minus. There's no need for the opposite. Do you see that? So when it says on this question that I want 21 or higher, I should think to myself, oh, I need to do opposite, because the calculator doesn't do higher. It only does less. That's just how they wrote the program. They could have wrote it different, but this is how they wrote it. The calculator only understands less, the binom CDF routine. So then I can't do more, and my question is more, so I got to do the opposite. What's the opposite of my question? 0, 1, 2, all the way to 21. Right? You with me? Or I could just say 21 or less. How about that? That's not true. 20 or less. 20 or less is the opposite of 21 or more, isn't it? Right? If I met somebody, a student, and I said, hey, are you 21 or more? And they said no, that means they're 20 or less. That's the opposite, right? So 20 or less is the opposite. So that means if I stick a 20 in here, it'll do 20 or less. And then I've got to do 1 minus the answer. and I'll get what I want. Do you see how that works? So number of trials is still 35. Probability is still 0.60. And I'm going to put a 20 here, and it'll do 20 or less, which is exactly the opposite of what I want in this problem. So after it gets that answer, then I'll go 1 minus, and do you know where the answer button is on your calculator? In the lower, have we done that before? I can't remember. Lower right corner above the negative button. Above the negative button, there's answer. So that'll grab the last answer on your screen. Super convenient button. So literally type in binom CDF 35, 0.60, 20. Hit enter. Hit enter when you're done with that. You'll get an answer on your screen, and then take 1 minus answer. Hit enter again, and you'll have the answer. I'm going to do it too. So here's what I got when I did it. So again, I literally typed in binom CDF 35, 0.60, 20, because that means 20 or less. I hit enter, and I got the answer 0.42, blah, 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 blah. And then I went 1 minus, hit the answer button, and hit enter again. And I got my final answer, which is 0.572, I guess it rounds to 8, 275, so 0.5728. There it is. Okay, so let's do part D. So one more fresh screen here. Part D, between 17 and 14, 17 and 24, including the 17 and the 24. So that one's most tricky. I wrote that one up for you. Let's go find that one. Here's the between. So for the between, you've got to do 2 binomials and subtract them.
Okay, that makes more sense.
2 binomials and subtract them. Why? Because the way they programmed the binomial function. So how did they program the binomial function? They programmed the binomial function to always mean and only mean that number or less. That number or less. So let's go to a fresh screen. If we want to do 17 to 24, that means 17, 18, 19, 20, 21, 22, 23, and 24, right? That's all the numbers between 17 and 24. How are we going to get that? You're going to need to take all the numbers 24, 23, 22, all the way down to 0, 24 and less, and subtract. In fact, actually, let me write out a little bit more here. Here, let me make that a different color too. So you're going to need to take 22, 21. Whoop, I'm just not getting it together here. 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, etc. 2, 1, 0, and take away from that, remove from that. Remember, this is my goal. My goal is to get 17 through 24. Right? Then I'm going to need to remove 16 on down. Aren't I? And then these will cancel, and I'll be left with 17 through 24. Do you see that? So again, look at what I'm saying here. If your goal is to end up with just the numbers 17 through 24, then you're going to have to take all the numbers up to 24 and remove the numbers up to 16. And you'll be left with the number 17 on up. Won't you? Do y'all see that? So one more time. If your goal is to have the numbers 17 to 24, then you got to go 0 to 24 and take away 0 up through 16. And what will be left is 17 to 24. Does that make sense? So you got to do 2 binom CDFs. Now, what does the binom function do? Only there and down, never up. Only down. That's how they programmed it. So I got to plug into the binom 24, and it'll give me 24 on down. And then I got to subtract and plug into the binom 16. It'll give me 16 on down. And the difference between those will be the 17 to 24.
So
That's what I'm describing.
Put in 16 instead of 17.
Right. See, notice this. Exactly. Did everybody see the pattern? Math is about patterns. It's improving better and better at dealing with patterns. So let me show you. So let's take a look at this right here. This number right there, notice, appears right there. Everybody see the pattern? The first number goes there in the first binomial, and the second number minus 1. See the pattern? Why minus 1? Well, because if you want, where did I have it? It's on the other screen. I keep forgetting where I'm writing. If you want 17 through 24, you got to subtract 16, one less, and on down, don't you? You see that?
In the first binomial, it's 35.
It's the actual number, and the second one, it's the other. Yeah, I'm going to write it out. So let's see it. So it's going to be the binomial CDF, and the beginning's always the same, right? Number of trials, 35, probability 0.60. And then what number, and then I'm going to subtract binomial CDF, and this is going to be 35.60. And this is going to be 24 on down, take away 16 on down.
Oh!
Right? 24 on down, take away 16 on down, huh?
That made no sense to me when it was like written out.
That'll leave you with 17 through 24, won't it?
6 up there.
Is that making sense? Hit the buttons on the calculator.
0.8262.
0.8262. Anybody else getting that?
Why do you put?
It's all about the pattern, right? So look back at the rule here. You see what I'm saying? If you have it, you'll have this exactly with you during the exam. And if you get a between question, you just grab the first the higher number, and that goes in the first parenthesis, the first binomial CDF, and then the second number, one less than that, goes in the second binomial CDF. See how the second one is always one less than the lower number. Do you see that pattern? So that's the pattern. All right, and the answer should be 8262 for that one. So these are all the same. I mean, literally the same. Questions 4, 5, 6, 7, 8. I think they're all going to ask you exactly the same questions. So how about I do one more with you? 80% of all bald eagles survive their first year of life. If 40 bald eagles are randomly selected, find the probability that exactly 33 of them survive their first year of life. Would you recognize that on the exam in a couple weeks, that's a binomial question? You'll see the exactly at most, at least, and you'll go, oh yeah. And you have your sheet with you, so you'll recognize that's a binomial. They either survive or they don't survive, right? 2 states, binomial. So then, how do we do how's the exactly different from all the other questions? PDF. Yeah, remember the sheet here. Exactly is the binomial PDF, isn't it? All the rest are cumulative. Because all the rest of the questions mean a range of numbers, don't they? If they say exactly 20 bald eagles survive, that's just one thin number. But if they say more than 20, that's 20 on up, or less than 20, that's a range of numbers. That's cumulative. That's CDF. All the rest are cumulative. But exactly, that's PDF. All right, so we'll do, for that one, binomial PDF, and it's always number of trials, probability, and in this case 33, exactly 33. So the number of trials, how many eagles? 40. On my problem anyway. 40 eagles, and the probability of an eagle surviving first year of life, 0.80. So put that in, hit the buttons. I'm getting 0.1513. Is that what you got? All right, 1513 is a 15% chance that you're going to have exactly 33 out of 40 bald eagles surviving their first year. About a 15% chance. That's what that means. 1513. About a 15.13% chance. And then what's the chance that at most 32 of them survive. Well, what does at most 32 mean? Yeah, it means 32 or less. Are you comfortable with that English phraseology? So when we say I've got it, at most 32 eagles survive, that means that's the most. Could be that or could be less. 32 or less. So anything that's less, we don't have to do the 1 minus. We just go in here and go, okay, at most, see the pattern? You just grab that number, put it in right there on the binomial CDF, and there's no need to do the 1 minus. So I'll do binomial CDF, 40 trials, 0.80 is the probability, and 32 or less. Hit the buttons on the calculator. 0.5629. There's a 56% chance that at most 32 or less of the bald eagles survive out of the 40 through their first year. So we're able to figure out probabilities of a lot of different things here. What's the chance that at least 34 of them survive? What if you need 34 for some other breeding program? You need 34 to survive. What's the probability that at least 34? 34 or more, right? 34 and up, yeah. So this means 34 or more. And that's not what the calculator naturally does. The calculator naturally only does below. That means 35 or more. So then we got to do the opposite. What's the opposite of 34 or more? 0 through 33. Right? That's the opposite of 34 or more. Is 33 or less. Right? Let me write it that way. The opposite is 33 or less. So that means I'm going to do my binomial CDF 40, 0.80. And I'm going to do 33 or less. So I'll put 33 or less. And then I'll do 1 minus the answer, because that's actually the opposite of what I want. I don't want 33 or less. I want the opposite of that. I want 34 or more. I'm getting 0.2859. They want 4 places anyway. Not coming out, if you're doing my exact example. And then finally, they want me to go between 31 and 38. So the between, remember how that works? So we'll go back to the between. Here, let me get a fresh screen. So the between, what you always do for the between is you got to go 38 on down to 0, subtract 30 on down to 0. The difference will be 31 to 38. Right? So you got to do, that's what this says here. Right here. Notice on the binomial CDF, you got to take the higher number and put that one first. And then the lower number goes second minus 1. That's the pattern. That's what makes sense. Binomial CDF. So the first number, well, I gotta do the number of trials. I'm at 40. 40 trials. Probability. 0.8 and 38. There's the first number. Minus binomial CDF 40.8, and then 30, because that's 1 less than 31. Everybody see the pattern? You take the lower number, 31 minus 1, and you put that there, and that becomes 30. So if you want to get the numbers between 31 and 38, you got to take 38 on down and subtract 30 on down. What's between them will be 31 to 38. Answer?
0.7303.
0.7303. There we go. Is that good? Are we happy about that? Are you extremely happy now about that? So number 9. Now getting back to the gambling thing, this will be quick. A gambling game is played with expected value 0.40. That means there's a 40% chance of winning. Is that true or false? Yeah, false. Well then, what does that 0.40 expected value 0.40 mean if it doesn't mean there's a 40% chance of winning? Average gain per roll or game that you're playing. Right? Well, I should say per game. Every time you play the game, on average, you're going to make 40 cents. It doesn't mean there's a 40% chance of winning. It means you're going to make 40 cents on average every time you play the game. Number 10. If a business owner who is only interested in the bottom line computes the expected value for the profit made on a bidding on a project to be negative 3,000, if that's his expected value, then this owner should not bid on the project. For sure. Yeah. On average, he's going to lose $3,000. Now, something miraculous might happen. He might make money on the project. But on average, if he keeps bidding on projects like that, he's going to be losing money regularly. Not a good thing to bid on. So number 11. If the expected value for a $5 raffle ticket is 85 cents, that means there's an 85%. Yeah, that's false. Same question. Number 12, if the profit on a raffle ticket is minus $5, then most likely outcome is a net loss of $5. Is that true? False. Think more carefully. Think more carefully. So what is expected value again? Average gain or loss. That means on average you're going to lose $5. Right? That doesn't mean that's what's going to happen when you buy one ticket. It might be impossible to lose $5. Remember some of those games we did earlier? I have to go way, way back. But we did so. They're not. Yeah. Are they there? Yeah, remember some of these? We came out with a negative 1.66 on this one. There's no way to play that game and lose 16 cents. That's just the average. That doesn't mean that's what's going to happen on one roll or one play. That's just the average when you do it lots and lots of times. Right? So they're testing to make sure you're really clear. That's the average. It's not what's going to happen on any one roll. It's not probability. That's the average. It's not the most likely outcome of one. It's not what's going to happen with one purchasing one thing. It's what's going to happen if you purchase lots and lots of them. It's going to be your average result. So that they're being a little tricky there, aren't they? So that one's false. Okay.